In today's video, we'll try to understand the concept of clockwise and anti-clockwise movements. So let's begin the topic. When a body is fixed at one point and when you're applying the force from the left side and the body rotates from right to left, then it is known as clockwise movement. And suppose you're applying the force from the right side and the body rotates from left to right, then we'll call it as anti-clockwise movement. So like this, you should be able to identify which is a clockwise movement and an anti-clockwise movement. As you can see here, a disc is pivoted at one point. And when you're applying the force from the left side, you can see that the disc is rotating from right to left. Can you guess which type of movement of force it is? Yes, it is clockwise movement of force. Similarly, here you can see that the force is applied from the right side and the disc is rotating from left to right. Can you guess which type of movement of force it is? It is nothing but anti-clockwise movement of force. So here the clockwise movement of force is taken as negative and anti-clockwise movement of force is taken as positive. So let us understand movement of force with few examples. So let's start with example 1. So here in the image you can see one door is there and I have marked here 3 points, that is point 1, point 2 and point 3. So when you are applying the force at point 1, that is at the door knob, you can see that the door will open very smoothly and easily. Why? The distance from the point 1 to the fixed point, that is point 3, is more. When the perpendicular distance is more, what happens? Force will be very less. You need to require very less force to open the door. Now change the location of the applied force. Now apply the force at the point 2. What happened? You can see the distance from point 2 to point 3, that is fixed point, is decreasing. When the perpendicular distance is decreasing, automatically you need to increase the applied force. Distance is decreasing, force is increasing. Now apply the force at the point 3, that is fixed point. What you will observe? You will observe that the door is not opening. Why? Because you are applying the force at the pivoted point itself. So that's the reason the door will not open. So point 1 less force, point 2 you applied more force comparing to point 1. Point 3, that is fixed point, that is also known as hinged or pivoted point. What happened? The door was not opening. The reason? The moment of force is 0. Observation: first point, less force, moment of force is more. Point 2, more force you applied, but moment of force was very less comparing to point 1. Point 3, what happened? There is no movement in the door. That means moment of force is 0 or torque is 0. Example 2. In this image, you can see a woman is using a stone hand floor grinder and you can see that the handle is placed near the rim. The reason is how far the handle is placed away from the pivoted point, that much less force is required to increase the moment of force. So that's the reason always the handle is placed near the end of the rim. Example 3. In this image, you can see a steering wheel is there and you know that it is fixed at one point at the center. And when you're applying the force at the point O, you can see that it will rotate from left to right. That is nothing but anti-clockwise rotation. So here also what is happening? You're applying the force far away from the pivoted point. So that means larger the perpendicular distance, less force is required for more movement of force. Similarly, in this image, you can see that when you are applying the force at the point P, the steering wheel will rotate from right to left. That is nothing but clockwise rotation. And here also you are applying the force far away from the pivoted point. So from these examples, you can understand that larger the perpendicular distance, less force is required for more movement of force. Conclusion: from these examples, we can conclude that when the perpendicular distance is larger from the pivoted point, then the less force is needed to turn the body.